In this video, I'll show you how to solve the ALEKS problem called Interpreting the Electron Configuration of an Atom or Atomic Ion in Noble Gas Notation. So this problem is going to give us an electron configuration that uses a noble gas abbreviation, and it's going to tell us that it is either a neutral atom, or it's an anion, or it's a cation. And if you have an anion or a cation, it's also going to include the charge of the anion or the cation. I don't have that. We're going to kind of pretend like I do, but you'll be given all of that information in the problem. Now for this problem, I think that it's easier if we solve it from the bottom up, starting with the last question. The last question is asking us to figure out how many 4p electrons we have. To do that, we're going to focus on the 4p portion of the electron configuration. The number that's in the superscript is the number of electrons in that orbital. Second question is asking us how many electrons the atom has. So to do that, we're going to be adding up all of the superscripts, plus, don't forget the noble gas abbreviation. We have to add the electrons up for that as well. So let's go to the periodic table and find argon. Argon is element number 18. That means that it has 18 protons, and it also means that it has 18 electrons. We're going to add that to the 2 electrons that are in 4s, and the 10 electrons that are in 3d, and the 3 electrons that are in 4p. That's going to give us a total of 33 electrons right here. Now, what we do next in terms of answering this question right here is going to vary depending on if you've been assigned a neutral atom, or maybe you have been assigned a cation, or maybe you have been assigned an anion. We have to figure out the chemical symbol for the atom. To do that, I'm going to add kind of a little side question. We need to figure out how many protons we have in this atom or ion, because the number of protons is what dictates the identity of the atom or the ion. If you have a neutral atom, the number of protons is equal to the number of electrons. So if we are neutral, which in this problem I am, the number of protons is going to be equal to the number of electrons, and for me that means that it's 33. If I have a cation, if you have a cation, that means that the number of protons is greater than the number of electrons. And if you have an anion, that means that the number of protons is less than the number of electrons. Specifically, the difference between protons and electrons is going to be given to you in the charge. So if you had, like, let's say if this problem was for a cation, it will tell you in the problem what the charge is on that cation. It'll say like it has a charge of +1, and that charge is telling you that you have exactly 1 more proton than electron. So whatever number is associated with the charge, that's going to tell you how large the difference is between the protons and the electrons. Because I have a neutral atom, my protons are equal to my electrons. Once you get it figured out, however many protons you have, you're going to go to the periodic table and look for that element. I have arsenic. That's element number 33. And because it's neutral, there's no charge. Let's just kind of pretend, just so that you can see an example, let's just kind of pretend that this said it was a cation with a charge of +2. What would I do in that case? So if I had a cation with a charge of +2, that would mean that I have more protons than electrons. So that means my number of protons is going to be greater than my number of electrons, which is 33. And the magnitude of the charge is telling me how much greater it is. So greater than 33 by 2 would mean that I would have 35 protons. Then I would go to the periodic table to find element number 35. That's bromine. And then also I would remember I have to include the charge when I write the symbol for the bromine in this box right here.